You guys are going to look at the investigation you did yesterday. We're going to discuss the answers. So even if you didn't get them, the idea here was to find patterns. So as we discuss them, look for those patterns with us. And those of you that did complete it can check the responses that you got. So our goal here is to kind of study three-dimensional objects. So your creatures are three-dimensional objects. Right? So it's not like growing in one dimension. We are measuring single things about your creature, but your creature is a three-dimensional object. So we want to look at other three-dimensional objects and see what happens to them as they grow. So in this investigation, you looked at a rectangular prism and you looked at cylinders, and you had a smaller one that had a scale factor that grew it into a larger one. Okay? So the first thing I want to talk about is that word scale factor. So a lot of us didn't know what that was when it was mentioned in here, but a scale factor is just a comparison when one of those objects does grow from the beginning size to the ending size that you're looking at. So all of these, notice when you took those sides, and even the perimeters, you got different values, but when you reduced them in the ratio, they all reduced down to 2/3. Okay? That's what your scale factor is. It's saying anything you can measure with the measuring tape about this, when you compare one on the smaller to one on the bigger, it's always going to reduce down to 2/3. Okay? So you guys got a length ratio of 2/3. I'm calling it length, but it could be any kind of length. Perimeter is also a length. Could you take a tape measure and measure the perimeter all the way around something? Yes, then it falls into the category of length. Okay? Area and volume are different because you can't just measure them with a tape measure. You have to have measurements from the tape measure, but then you have to do some arithmetic with them to actually figure those things out. So I wouldn't expect area and volume results to be the same as length, because length I can just measure, and area and volume I have to do some more operations to get. So when you guys did the area, it asked you to do two different area calculations. One for just a piece of the rectangle, like you just did the top rectangle of the solid. But then they also asked you to do the entire surface area. And notice these areas were much smaller than the entire surface areas, but still when you compared the small one to the large one, the ratio still reduced to the same thing, whether I was doing just area of a piece or area of the whole thing. So that means that area always kind of works out the same, but did we get the same thing as we did with length? Did we get 2/3? Okay. No, we got 4/9. So not the same number, but there is a relationship. So I'm just keeping track of them here so we can look at that relationship because it asks you about it later. And then you guys went and calculated volume later on, and your volume ratio should have reduced to 8/27. Okay. So here's a summary of what I have. The length or the scale factor between any single measurement was 2/3. Any comparison of the areas reduced to 4/9, even though I said it, I wrote 3. And the volume reduced to 8/27. So the questions in here asked you, they said, okay, they're not the same, but can you compare them? What can you do to this length ratio of 2/3 that would turn it into 4/9? Square it. Okay, so these basically have a relationship where if I square the length, it would turn into the same ratio that I'm seeing for area. Okay, and again, these are the comparisons, the ratios, not like the actual values. Right? Then they asked you, what's the relationship between length and volume ratios? What operation can you do to 2/3 to get it to turn into 8/27? You can cube it. Okay? And that kind of makes sense because when you're doing area, you're often squaring things, right? Our measurements are in squares because we multiply two things together. But when we do volume, our measurements are in cubes because we're multiplying 3 different dimensions together. Okay? So when we look at the cylinders, you guys did the same thing again, this time with cylinders. You looked at comparisons of the radius, comparisons of the height. You even looked at circumference, but circumference, just like perimeter, you can measure circumference with a single tape measure. So it's not an area or a volume, it is just a length. Okay? So all of those different measurements all reduced to 2/5. Okay? So the scale factor here, or anytime we compare any lengths, we just get a ratio of 2/5. Then you guys went on and again you calculated two different areas. One time of a small piece, just of the circle, and you compared an area of the small one to the large one. And then the entire surface area of the cylinder, small compared to large. And again, even though those values were different, when we compared the small to the large, they reduced to the same ratio of 4/25. So in this case, anything that has to do with area, whether it's area of just one part or area of the entire cylinder, they're going to compare small to large, will reduce to 4/25. And then you guys did volumes. And when we reduced the volume ratio, we got 8/125. So here's the summary of the numbers you got from the cylinder. And then you were asked the same thing again. What could you do to this length ratio? So this comparison between single lengths of the object, in order to obtain the same value that we see for the area ratio. So again, what is the relationship between the length ratio to the area ratio? Squaring again, right? So even though we switched to cylinders, still these ratios would be squared. Okay? And then how do we get from a length ratio to a volume ratio? Cubing. Is this idea okay with everybody? Okay, that's kind of the big idea, but I'm not going to lie, like the smaller nitty-gritty stuff, this tends to be like the hardest thing for people to grasp in Unit 1. So today we're just going to talk a little bit about how to organize the information and answer the simplest version of the questions, and then tomorrow we'll look at more complicated versions, and then you'll have homework that you can work on that's due on Monday to see if you can apply it or not, okay? So here's the idea. I'm going to go to the very last question that you guys were given in here. So I'm going to try and organize it this way. In years past, I think the questions are kind of tripping people up because they're trying to skip right to an answer. And when they're doing that, they're losing track of what they're trying to find. So here's what I'm going to say. I'm going to say that because we just found out the information that we know, that if we square the length ratios, we can get the area ratios. And if we cube them, we can get the volume ratios. Anytime somebody tells us a comparison between a smaller and a larger object, they're giving us one of these, and then we should be able to find the other ones, okay? What you should have kind of in your head in order to find that, and you can organize it a different way if you want, but I'm just going to say how I say it. The length is like one number compared to another. So this time I'm not using a specific number. Right? Those numbers were specific for those shapes, and I want to kind of generalize it so I can use it for anything that anyone gives me. When they give me a length, they're just saying, hey, here's how the first one compares to the second one. And they might write it like this, or they might write it like you guys wrote your scale factor as a fraction. Is that okay with everybody? The A and B just represent numbers like your 2/3 or your 2/5. Okay? If you know that this A goes with this B, for the growing of the creature or the growing of a rectangular prism or anything else, you should be able to find the other ones because we just looked at and determined that the area was just the square of those numbers. So if A goes with B for the length ratio, then if I just square the A and I square the B, I'll have the numbers that I need for my area ratio. Okay? Or again, if you guys look at it in fraction form, like this. And so how am I going to write this for volume? How am I going to view that right now? Just the cubes of those first values, right? If I know A and B are the comparison of the lengths, that the volume is the cubes of those numbers. And we can use that to help us through different problems depending on what they give us. So I'm going to ask you guys to really focus on what are they giving me and fill it in here, and then see if you can fill in the other stuff. Then go back to the problem and answer questions, because I think that will help you categorize your information and you won't miss out on some of the pieces. If you're really good at this and you don't need to do this, that's totally okay. But this is a place that people struggle every year, so I've been trying to like change it up and organize it for you guys in a way that you can answer the questions that they're asking you. So when we look at this first question here, the given information is right here. Scale factor of two similar pyramids is 4:3. That's what they're handing me. Now I have to interpret what kind of information they're giving me. They clearly are giving me a ratio. Okay, is it already reduced? Yeah, 4 and 3 don't have any more common factors, so that's good. They're giving me a reduced ratio. Now I have to be able to recognize which ratio this actually belongs with. So when they say the scale factor of two similar pyramids is 4 to 3, does that 4 to 3 represent a ratio of length, area, or volume? So when you did your investigation, when you pulled out the scale factor, was that after you just compared lengths of the figure? Or was that after you did an area calculation or after you did a volume calculation? So look back and see. Okay? I'm going to scroll back to the beginning here. Here's where I answered question about scale factor, right? The scale factor of these was 2/3. Where did 2/3 come from? Did I have to do an area calculation or a volume calculation to get this? No. I just pulled pieces straight off of there. So they were just based on a single length measurement from my objects, okay? So that means in this chart, when somebody says scale factor, it falls into which category of measurement? Length, area, or volume? Length. It's just based on simple measurements of length. What else would fall into that category? So scale factor falls into that category. What if I said the right side of it is 5 centimeters, like one right side of it? Is that a single length of the piece? Yeah, so that would fall in there. If I give you a length, a width, or a height, are those all things you could just measure with the tape measure along the edge of the box? Yes, they all fall into that category. What about perimeter or circumference? Can you measure them with a tape measure?
No. When?
Did you measure circumference of your creature with a tape measure? You should have. It was on the list of things to measure.
Oh, okay, no.
Did you? Did you wrap the tape measure around your creature and measure some sort of circumference? Okay. So circumference and perimeter are things I can measure with a tape measure. All of those things are in this category. Okay? Does that make sense to everybody? In order to be in this category, I would have had to have calculated some sort of area, a surface area, a lateral area, a base area, the area of one side, something like that. And in order to be in this category, I would have to have calculated a volume. Is that all right? So when they say scale factor, that falls into this category. Okay, so I'm going to fill that in right now. They are giving me this information that this is 4 to 3. And then before I go answer anything, because our problems are going to vary, I want you to just gather all the information that you know from that. And again, if you're like, no, Ms. Dahl, I can do this without it, more power to you. I'm not saying like if you don't do it this way, I will mark you wrong. I'm saying in years past, everybody struggles with this, so I'm trying a new strategy, okay? So if we know this, what I can then go in and fill, this means that A is 4 when B is 3. That I can let this thing I'm calling A, the first number in my ratio, I'm going to let that be 4 because I'm going to let the second number be 3. And that means when I get to these other ones like area, instead of A squared, I can think of it as 4 squared. And instead of B squared, I can think about it as 3 squared. And so I know the area ratio should be 16 to 9. And then for volume, I can do the same thing. The A is a 4 in this problem, and the B is a 3. So I can think about this as being 64 to 27. Is that okay? All right, now I'm going to go answer the questions. All right. First question wants a ratio, which is good because I have a bunch of those right here ready to be used. Okay. It wants a ratio specifically of base areas. Which category do base areas fall into? Are they a length, like a measurement, an area calculation, or a volume calculation? Read the name. An area calculation, right? So base areas fall into this category. They are a representation of some sort of area, and therefore they would use the ratio that corresponds to that. So the answer to that question would be 16 to 9. The next question asks us to compare or write the ratio of surface areas. Which category should I be looking there? Again, an area, right? All the areas, whether I found one piece of area or the whole area of the object, reduced to the same ratio, So it's okay that these are the same answer. That doesn't mean the base area and the surface area are equal. It means when you compare the small one to the big one, they reduce to the same number. Okay? And then the last one says the ratio of volumes. Which category does that fall into? Volume, okay? And then that will be 64 to 27. So is the basic idea of this okay? What you're going to have to know from this is this relationship. This isn't really a formula. This is just a way to write down this relationship that I'm seeing that is something that you're going to be responsible for knowing, okay? That if you know this ratio, a ratio of areas is the squares of those numbers, and a ratio of volumes is the cubes of those numbers. And then we're going to try and interpret more problems tomorrow that are a little more difficult. Like, what if they don't give us this one? What if they give us this one? How do we work backwards and some different things like that? Okay. Make sure, if you didn't already,